Okay, I'm recording. All right, increasing, decreasing. They're asking where's the graph increasing. They're talking about the x values. So it's going from, let's say, negative infinity, increasing, 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 all the way up to this max right here. So whatever that x value is, it's increasing from negative infinity up to, let's just say that's like negative 5. Okay? Then it's decreasing all the way down here, and let's say that value is 3. Okay, so we don't need that interval. But it's also increasing again from 3 to infinity. And you don't have to worry about brackets or hard brackets because the questions on the test just have all soft parentheses. But increasing and decreasing is only soft parentheses, soft brackets, because the slope at the max there is actually 0, so it's not increasing anymore, so we don't include those values. Nobody cares though, it's fine. Okay, so what's next? I'm trying to be quick so you guys have time to take the test. Interval, this is the hardest thing for most people. Where's the graph of f of x? Say this is f of x. Greater than or, let's do greater than or equal to 0, okay? Greater than or equal to 0. So if I had a highlighter, oh my gosh, this fan. This is where all f of x is y. This is where all the y values are greater than 0, right? Because here, this is y, and oh, that's a terrible y. 1, 2, 3, these are all positive values, right? 1, 2, 3. Here, these are where the y values are negative. And they're asking where is f of x, where is y greater than 0? So it's up here. So we just need the intervals from, oh gosh, this fan. Okay, from here to here, here to here, and from here to infinity. Now if it said greater than or equal to 0, these points are equal to 0, you would include those values. If it says just greater than 0, then you don't include the values. Are we good on increasing, decreasing?
Yeah.
I don't think I gotta spend time on that. Oh, you know what I do need to spend time on though? You get a function that's like, I don't know, f of x over g of x. And let's say you make your fraction, let's say it's like x over x squared plus 9. Okay, I went over this once, but I need to go over it again. If this was a minus 9, the denominator would be 0 at 3 and negative 3, right? However, a plus 9, if I went ahead and set that equal to 0, I'm like in front of my camera here. Okay. Imaginary number. We're not plotting any imaginary numbers. There are no values that we need to take out of our domain in this function. We would have to take out 3 and negative 3 if this was an x squared minus 9, because 3 and negative 3 would make the denominator 0. There are no values. We can plug in whatever we want for x. We're not going to get a 0 in our denominator here. Good? That's important. Muy importante para ustedes. Okay, I don't think I'm going to go over piecewise functions. Already did that. Range. This is hard. I'm not sure why. It's an algebra 1 and algebra 2 thing, but let's say the graph starts here and goes here, or something like that. I don't know. I'm just like making stuff up. The range is from this y value to this y value. We always do low to high. The range are all the possible y values. So if I made an XY chart, the range would be every single point on here would be all the possible y values. So if there's any y value, like let's say right here there was a hole, okay, we would not include that particular y value. However, sometimes you'll have a graph that, I'm making stuff up, it's like that. this graph's range would be from negative infinity up to, and you don't have to worry about the whole, because if that y value, we've got a point. We're covered up to this max right here. Yeah? I went over all this other stuff. Even odd? Should we do even odd again? Okay, so went over the concept. Let me move this. Got my graphs. Oh yeah, can I put it on your desk? So I already have them drawn here, so. Okay, so an even function, when you plug in a value for x, and you get a, let's say you get a positive y value. Let's say it's like 2 and the y value is 3, okay? So 2, when you plug in 2, you get 3. When you plug in negative 2, you still get a positive 3. Here, I guess I just have to redraw this graph. When I plug in 2, I get 3 for the odd function. However, when I plug in negative 2, I don't get 3 anymore. I get negative 3, which is why when we're looking at it algebraically, all the signs have to change. So if I take a function, what do you think? Okay, so let's say, I don't know, it's like x squared plus 2, okay? If I plug in negative x, what's gonna happen is that negative x, this is gonna become negative x times negative x. It's gonna be the same value. That's gonna end up, that's gonna stay x squared, and then my plus 2 will remain the same. So that function is going to be even, because none of the signs changed. The y values are still gonna be the same. So if I change this to a cubed, okay, now when I plug in negative x, negative times a negative times a negative, we get a sign change. However, this one didn't change. When you multiply through an equation by a negative, every term has to change signs in order for it to be odd. This one is neither. However, if I had made this an x, I'm plugging in negative x for my x, then the sign would change. Both terms have a sign change. That would be odd. Okay. And then when you're verifying, when you're asked to verify if two functions are inverses, you have to plug f of x into the inverse and the inverse into f. You have to do both. And then show your work on paper. And then to find the inverse of a function, you just switch the x and the y and solve for y. That's it. We good? Any questions?
Sorry, could you repeat how to check that again?
Check the
previous part.
The verifying?
Yeah.
So, the inverse has to undo the function. You have to be left with x. And then you also have to check if, when you plug in the function into the inverse, that undoes and gives you x. Sometimes, most of the time in pre-cal, it always works out because we're trying to teach you this skill. However, there are some like weird functions, especially ones that have like a restricted domain that end up with like a negative x or something. So you'd have to check both. Did that answer your question?
Yes.
Okay. I think we're done.